instead of, because we are taking input from the user, what if the user is somewhat malicious and types in a string instead of an integer, or maybe he types in a float or some other data type?
Yeah, so what if the user, like we've seen in past examples, types in cat instead of a number when we're expecting an integer? How do we test for something like that? At the moment, I'm admittedly not testing user input. If I go back to my code here, notice that my calculator function, of course, has the square function that we keep testing and retesting. But notice that all of the user input is currently relegated to my main function. And admittedly, as of now, I am not testing my main function. So there could be one of those bugs. And in fact, there would be, because if the user types in a string like cat instead of an integer like 2 or 3, then line 2, recall, would actually raise a value error exception. So we've seen that before. So when it comes to testing your code, this is actually a good reason for having multiple functions in your program. Rather than putting all of your logic in just the file itself, rather than putting all of the logic in just main, it's actually really good, really helpful practice to break your ideas up into smaller, bite-sized functions that themselves are testable. And what do I mean here? Square is perfectly testable. Why? Because it takes as input a parameter called n, and it returns as output an integer, which is going to be the square thereof, hopefully. It has a well-defined input and a well-defined output. It is therefore completely within your control in your test program to pass in those values. Now, I will say, if you want to test whether square behaves properly when passed something like a string, like quote unquote cat, we could absolutely do something like this. Assert that the square of quote unquote cat, it's not going to equal something. You can actually, using different syntax, assert that a specific exception will be raised. So if we were actually going to go back into our square function, improve it, and deliberately raise an exception, we could test for that too. But for now, I'm deliberately only testing the square function. I'm not testing for specific user input. But that's another problem to be solved. Other questions now on unit tests?
Do you use the unit test to test code for the cs50 check?
So cs50 is similar in spirit. cs50 is a tool that we, cs50, wrote that is essentially doing something like PyTest for the evaluation of students' code. It is similar in spirit, but think of cs50 as being an alternative to PyTest, if you will. But it works a little bit differently. But same idea. PyTest and unit testing more generally is a technique that is independent of cs50 and is something that you can and should be doing on your own code, both in or outside of this class. How about one other question here on our unit tests?
My question is, instead of writing 4 times like s square of 2 is equal to 4, instead of that, can we write if I is equals to, in square brackets, the numbers we want, instead of writing 4 lines?
A really good question. Absolutely. Right now, if I go back to testcalculator.py, it's indeed pretty manual. I mean, it took me a while to say and to type out those several lines. And you could imagine writing some kind of loop to just assert in a loop that this equals that this equals that, and so forth, using a list or using maybe a list or a dictionary or some structure like that. So yes, you can absolutely automate some of these tests by not just doing the same thing again and again. You can still use all of the syntax of Python to do loops. But generally speaking, your tests should be pretty simple. And in fact, let me propose that we improve upon even this design further, because at the moment, what's not really ideal when I run all of this, when I run all of these tests, when my function is buggy, is notice the output that I got. Let me reintroduce that same bug by changing my multiplication back to addition. Let me increase the size of my terminal window again, and let me run PyTest again of testcalculator.py. So this is the version of my code now that has the bug again. So I'm going to see that big, massive failure where this failure has been displayed to me. But this is not as helpful as it could be, right? Because I have all of those other tests in my code. Recall that I had, what, 1, 2, 3, 4, 5 separate tests, and I'm only seeing the output of the first. Now, why is that? Well, if we go back to my code here, you'll see that the first assertion that's failing, namely this one here, that assert of square of 3 equals 9, the other tests aren't even getting run. And that's not a big deal in the sense that my code is buggy, so one or more of them are probably going to fail anyway. But wouldn't it be nice to know which of them are going to fail? And in fact, it's ideal to run as many tests all at once as possible to give you as many clues as possible to finding your bug. So let me propose that we improve the design of my testing code now, still using PyTest as follows. Instead of having one big function called test square that tests the entire function itself with so many different inputs, let's break down my tests into different categories. And here, too, there's no one right way to do this, but my mind is thinking that I should maybe test positive numbers separately, test negative numbers separately, and test zero categories. And here, too, different inputs, let's test. So let me propose that we improve the design of my testing code now, still using PyTest as follows. Instead of having one big function called test square that tests the entire function itself with so many different inputs, let's break down my tests into different categories. And here, too, there's no one right way to do this, but my mind is thinking that I should maybe test positive numbers separately, test negative numbers separately, and test zero separately. I could think of other ways. I could test even numbers, I could test odd numbers, or maybe some other pattern altogether. But separating this big test into multiple tests is probably going to yield more clues for me when something goes wrong. So let me do this. Let me go ahead and rename this function to test positive initially, and let me include in that function only those first two tests. Let me then create another function here called test negative. And in this function, let me test only -2 and -3. Then down here, let me do one more def of test 0, and I'll just run one test in there. So I have the same assertions, the same 5, but I've now divided them up among 3 separate functions. What's nice about PyTest and other unit testing frameworks is that all 3 of these test functions will be run automatically. Even if one of them fails, the others will be attempted. That means that if 1 or 2 or 3 of them fail, I'll have 1 or 2 or 3 clues now for helping me find that mistake. So let me go ahead and, again, increase the size of my terminal window, just so we can see more on the screen. My calculator still has the bug using addition instead of multiplication. Let me go ahead and run not Python, but again, PyTest of testcalculator.py, crossing my fingers as always. And now, oh my God, there's even more errors on the screen. But this in itself is more helpful. Let's work through them from top to bottom. So under failures here, in all caps, which I know is not very encouraging to see failure when you're just trying to solve a problem, but that's what these frameworks do. Under failures, the first function that failed is test positive. But here, too, we see the same clue as before. The first one, 2, the square of 2 equals 4, that one's fine. It's not erring with any red errors. But the next one is failing. So I know that square is broken when I pass in 3. All right, what about down here? It looks like, unfortunately, my test negative function is failing too. Why? Well, when I pass in, oh, this is interesting. Here now, -2 doesn't even work. So I got lucky with +2, but -2 isn't working. So that's a bit of a clue. But in total, only 2 tests failed. So notice at the very bottom, this summary, 2 failed and 1 passed. What's the other one? Well, it was the third one, test 0. So test 0 is passing. These 2 are failing. And so that kind of leads me logically, mathematically, if you will, to the source of the bug. And just to be clear, too, if you have a lot of tests, this little one-line output is helpful, even though also a bit discouraging. Fail, fail, and dot means pass. So there are the 3 tests, just depicted graphically a little bit differently. Well, let me rewind now and go back into calculator.py. Let's fix that bug, because let's suppose that I've deduced, OK, I'm using addition. I should have been using multiplication all this time. Let me now, after fixing the bug yet again, let me go back to my big terminal. Let me run PyTest of testcalculator.py, hitting Enter, crossing my fingers now, and ... means all is well. 100% of my tests passed, all 3 of them. So now I'm good. It doesn't necessarily mean that my code is 100% correct, but it does mean that it has passed 100% of my current tests. And so it would probably behoove us to think a little harder about maybe we should test bigger numbers, maybe we should test even smaller numbers, maybe we should test strings or something else. The onus is ultimately on you to decide what you're going to test. But in the real world, you're going to be very unhappy with yourself or someone else. Maybe your boss is going to be very unhappy with you if you did not catch a bug in your code, which you could have caught had you just written a test to try that kind of input. All right, let me pause again and see if there's any questions now on unit testings with PyTest.
So if you wanted to test, like someone suggested before, user input as well as testing your function, do you do that within the same file, or do you make separate files for different types of tests?
Really good question. You could absolutely make separate files to test different types of things. Or if you don't have that many, you can keep them all in the same file. At the moment, I've been storing all of my tests in one file for convenience, and there's not terribly many of them. But we'll take a look in a bit at an example that allows me to put them into a folder and even run PyTest on a whole folder of tests as well. So that's possible. Other questions on unit testing?
So I've got 2 questions. A couple of while ago, you just used an exception called assertion. I'm not sure what was. Oh yeah, assertion error. What exactly does that particular error catch? And my second question is, does the assert keyword stand out to the compiler and exactly tell them to assert this particular line of code?
Indeed. The assert keyword we're seeing and the assertion error we saw earlier are intertwined. So when you use assert and the assertion fails, because whatever Boolean expression you're using is not true, it's false, an assertion error by definition of Python will be raised. So those two work in conjunction. Those errors, those assertion errors, are still being raised by my code here when any of these lines of code fail. However, PyTest, this third-party library, is handling the process of catching those exceptions automatically for me so as to give me this standard output. So we started today's story by really implementing unit testing myself. I wrote all of the code myself. I wrote main. I did my conditional. I did try and except. Honestly, it's going to get incredibly painful to write tests long term if you and I have to write that much code every time, especially when our function is this small. So PyTest and unit testing frameworks like it just automate so much of that. Essentially, PyTest adds the try, the except, the if, the prints for you, so you can just focus on the essence of the tests, which really are these inputs and outputs. How about time for one other question here on unit testing as well?
Sir, when we enter -6 or -5, the square root of that number comes up. But when we put 6.6 or 5.6, something like that integer, then line shows error. So what's happening there?
So if I'm deliberately testing integers right now, in large part because I only want POW to operate on integers. And that might be conveyed in Python's documentation or my own documentation for that function. If we were to pass in something else like a float, it turns out that floating point values in Python and other languages are actually very hard, if not impossible, to represent 100% precisely. And so if you are trying to compare it against some other value, they might be slight rounding errors as a result. I'm just inferring from what you've described, but I'm very deliberately now testing this function with only the inputs that I would expect. It might indeed throw other errors if other inputs are passed. All right, allow me to propose that we consider what should happen if square isn't actually passed a number. For instance, if I go back to calculator.py and suppose that I, or perhaps someone else using my square function, simply forgets to convert the return value of input from a str to an int, as by modifying line 2 here. Well, now something's definitely going to go wrong if I type in a str instead of what appears to be an int. For instance, if I clear my terminal here, run Python of calculator.py and hit enter, let's type in cat as our value for x. And of course, this raises now a type error. Why? Can't multiply sequence by non-int of type str. What does that mean? Well, you can't do cat times cat because indeed square is expecting that n will be some number. But that doesn't necessarily mean that square itself is buggy, but this does mean that if I expect a type error to be raised, let's test for that too so that I know the behavior indeed works as expected. So let me go back to testcalculator.py and let me go and add a fourth test down here. How about define test underscore, and I'll call this test stir because I'm going to specifically and deliberately pass in a stir for testing. And I want to, in spirit, assert that passing in something like cat to square will raise a type error, but we don't use the assert keyword for that. Rather, we need this. Let me go to the top of this file, and let me additionally import the PyTest library itself, because it turns out there's a function in that library called raises that allows me to express that I expect an exception to be raised. And I can express that as follows: with pytest.raises, and then in parentheses I can pass in the type of exception I expect, which is going to be a type error in this case. And now when do I expect that type error to be raised? Whenever I do something like calling square and passing in not a number, but something like cat. So now if I go back to my terminal window, run pytest of testcalculator.py, this time having 4 tests, I should see that all 4 now are successful. All right, let's now consider how we could test code that doesn't just expect numbers as input, but actually strings. And let me rewind us in time here in VS Code to that very first program we wrote a few different versions of in hello.py that ultimately looked a little something like this. I had a main function that prompted the user for the value of a variable by asking them, what's your name, question mark. And then we went ahead and did something like hello, open paren name, passing that user's name into a function called hello. Now that function hello, recall, ultimately looked like this. We defined hello as taking function version. Find us in time doesn't just this time having 4 tests, I should see that all 4 now are successful. All right, let's now consider how we could test code that doesn't just expect numbers as input, but actually strings. And let me rewind us in time here in VS Code to that very first program we wrote a few different versions of in hello.py that ultimately looked a little something like this. I had a main function that prompted the user for the value of a variable by asking them, what's your name, question mark. And then we went ahead and did something like hello, open paren name, passing that user's name into a function called hello. Now that function hello, recall, ultimately looked like this. We defined hello as taking a parameter called 2, the default value of which was world, and that function very simply printed hello followed by a comma and then whatever the name that had been passed in. And then we ultimately called main, but for now onward I'm going to always add this if conditional, if name equals underscore underscore main, then and only then do I want to call main. So that's essentially what this program looked like in its last incarnation. How do we go about testing it? Well, here again, too, I'm not going to test the user's input per se in main. I'm going to focus really on the module of code here that's of interest, which is the hello function itself. How can I go about testing the hello function? Well, unfortunately, even if I start by doing something like code of test hello.py, let me go about and start writing a test program. I could import from my hello program a function called hello. So a bit strange to see from hello import hello, but notice that on this line here, I'm importing from the module, that is the file called hello.py, the function called hello. And how do I go about testing this? Well, if I have a function like define test argument like this, well, let me do this. So if I were to define a function like define test hello, what could I do? Well, I could call hello with quote unquote, say, David, and then check if it equals what? Hello, comma, David? So would this work, this approach here? If I've written a test called test hello that calls hello with an argument of David and then tests its return value, just like we've done for our calculator, would this work as written? And let me go back to, in just a moment, the version of hello that we're testing so you can see that function hello. Here's the test. Here's the actual code. Would this test now work? Any thoughts?
I think the problem is that in the first version in hello.py, you're using the tow argument that you first declare when you declare the function instead of using the name.
OK, that is actually not a bug here. So let me stipulate that in hello.py, this code actually does work as intended. And let me go ahead and test it manually just to demonstrate as much. Let me run Python of hello.py, typing in as my name David, and I see, in fact, that it says hello, David. If, though, I were to change this program and get rid of the name argument, get rid of the name variable, and just call hello, again running Python of hello.py, this time I'm not even prompted because I got rid of my input call, but it does behave as I expect. It does say hello world. So let me stipulate that this code in its current form is actually correct, but my test is not going to work as I'd hoped. And there's a subtle difference between hello versus my pow function that there's a subtle difference between my hello function and my square function that explains. Why might this test not work as intended?
Because it's not returning a value.
Yeah, exactly. Recall our discussion early on about functions. Functions can either return a value, like my square function hands you back the square of some value, or they can have side effects, sort of visual artifacts that might happen on the screen, like printing something out on the screen. And by definition, that's how print works. Notice that hello, it is short, but it's implemented ultimately using the print function, which does not return a value as I'm using it here. It instead has this side effect of printing something onto the screen. So it is not correct in my test function to check if the return value of hello equals hello, David, because again, hello is not returning anything. It's printing something with that side effect, but notice literally it has no return keyword, unlike my square function, which did. So here's an opportunity, too, to perhaps change how I go about implementing my actual functions. It turns out that as your programs get more and more sophisticated, more and more complicated, it tends to be best practice not to have side effects if you can avoid it, especially if you want your code to be testable. And in fact, I'm going to propose that we change my hello program to now work as follows. Let me go ahead and change this function to not print hello and then that name. Let me go ahead and literally return maybe an f string, which will clean this up a little bit, hello, comma, 2, close quote at the end. So my syntax here is just the familiar f string or format string. It's going to return hello world or hello David or hello whoever's name is passed in as that argument. But I'm returning it now. I'm not printing it out. So what needs to change up here? Well, I could do something like this. I could say something like output equals hello, and then print output in my main function. Or I can simplify that because I don't really need that variable. I could instead just do this. I could still call hello, but I could immediately print out the result. And this version of my hello program now is actually more testable. Why? Because these assert statements that we're using, and we've seen thus far for our tests, are really designed to test arguments into functions and return values therefrom, not testing side effects. So if you're doing equals, you're looking for a return value, something that's handed back from the function. So that's fine. If I modify the design of my program now, not to just print hello, but to return the string, the sentence, the phrase that I want to construct, I can leave it to the caller, that is the function who's using this hello function, to handle the actual printing. Now what does this mean in my code? Well, it means now if my hello.py looks like this, and hello is indeed returning a value, in my test hello function, I can test it exactly like this. So let me go ahead and run pytest of test hello.py, crossing my fingers as always, and voila, one passed. So I passed this test because apparently the return value of hello does indeed equal hello, comma, David. Well, let's test the other scenario. What if I call hello without any arguments? Let's assert that calling hello with nothing in those parentheses similarly equals hello, comma, but world, the default value. Let me now go ahead and run PyTest of test hello.py, and that too passes entirely. But there too, suppose that I had made some mistakes, suppose that there were a bug in my code, it might not be best practice to combine multiple tests in this one function. So let's make it more clear what might pass or fail. Let's call the first function test the default to this function, and let's only include this first line of code. And then let's go ahead and define another function like test argument to test this other line of code here. So now I have two different tests, each of which is testing something a little fundamentally different. So now when I run my code, it's still not broken. If I run pytest of test hello.py, enter, I've now passed two tests. And that's just as good as before. But if I did have a bug, having two tests instead of one would indeed give me perhaps a bit more of a hint as to what's wrong. Questions now on this testing of return values when these return values are now strings instead of integers, and why we've done this.
So my question is about function inside the function. Can we test that too? Or recursion we have in C?
If you have a recursive function, which we've not discussed in this class, yes, you can absolutely test those too by simply calling them exactly in this way. Recursion does not affect this process. All right, how about one more question here on unit tests before we look at one final example?
When testing our arguments, like can we use something like loops or inside of asserts or for the values?
Absolutely. You can absolutely use a loop to test multiple values. In this case, for instance, I could do something like this. I could say for name in the following list of Hermione, say Harry, and Ron, I could then within this loop assert that hello of that given name equals, say, the format string of hello, comma, name, and then run all of these here at once by running, again, pytest of test hello.py. It's still going to be just one test within that function. But if there's something interesting about those several strings that makes it compelling to test all of them, you can absolutely automate the tests in that way. With that said, each of your tests should ideally be pretty simple and pretty small. Why? Because you don't want to write so much code, so much complicated code that your tests might be flawed. What we don't want to have to do is write tests for our tests and tests for our tests for our tests, because it would never end. So keeping tests nice and simple is really the goal, so that a reasonable human, yourself included, can eyeball them and just claim, yeah, that is correct. We don't need tests for our tests. All right, how about one other feature? Suppose that we don't have just one test, but many different tests instead, and we want to start to organize those tests into multiple files and even a folder. Well, PyTest and other frameworks support that paradigm as well. In fact, let me go ahead and test hello.py using a folder of tests with technically just one test, but it would be representative of having even more in that folder. I'm going to go ahead and create a new folder called tests using makedir at my command line, and then within that file, within that folder, I'm going to go ahead and create a file called testhello.py. Within this file, meanwhile, I'm going to test the same things. I'm going to go ahead and from hello, import hello. And I'm going to go ahead and define a function like test default that simply tests the scenario where hello with no arguments returns hello. Comma world, and I'm going to have that other function where I test that an argument is passed, and in this case I'll choose an argument like asserting that hello, quote unquote, David equals indeed hello, comma, ahead and define, I'm going to go ahead and from hello test default that simply tests the scenario where hello with no arguments returns hello, comma world. And I'm going to have that other function where I test that an argument is passed. And in this case, I'll choose an argument like asserting that hello, quote unquote, David equals indeed hello, comma, not world, but David. So in this case, I've just recreated the same test as earlier, but they're in a file now in a folder called test. Well, PyTest allows me to run these here too, but to do so, I actually need to create one other file. Within my test directory, I need to create a file called __init __.py, which has the effect, even if this file is empty, of telling Python to treat that folder as not just a module, but a package, so to speak. A package is a Python module or multiple modules that are organized inside of a folder. And this file, __init __py, is just a visual indicator to Python that indeed it should treat that folder as a package. If I had more code in this folder, I could do even more things with this file. But for now, it's just a clue that it's indeed meant to be a package and not just a module or file alone. What I can now do in closing is run PyTest, not even on that specific file, but on a whole folder of tests. So if I run PyTest of test, where the test is the name of that folder, PyTest will automatically search through that folder looking for all possible tests. Granted, there's just those 2 in this one file, but when I run it now with enter, I'll still pass those tests, I'll still get 100%, and I now have a mechanism ultimately for testing my own code. So whether you're writing functions that return integers or something else, functions that have side effects that could be rewritten as functions that return values, you now have a mechanism to not just wait for someone like us to test your code, and not just test your code manually again and again, which might get tedious and you might make mistakes by not including some possible inputs. We now have an automated mechanism for testing one's own code that's going to be even more powerful when you start collaborating with others, so that you can write tests that ensure that if they make a change to the same code, they haven't broken the code that you've written. All right, that's it for this week. We'll see you next time.